Hi, so today we're going to be talking about chemical doping of organic semiconductors. There are two types of doping. There's N-doping and P-doping. In N-doping, the dopant adds more electrons to the polymer semiconductor, and in P-doping, the dopants add more holes to the polymer, which is essentially removing more electrons. There's two types of chemical doping. There's integral charge and partial charge transfer doping. In the case of integral charge transfer doping for the N-dopant, here we have the energy diagram for the homolumo levels of the polymer and the dopant. As you can see, in the dopant side, the homolumo levels are a little bit higher or higher than that of the homolumo levels of the polymer. This is so that if we fill in all the electrons in the HOMO levels, the electrons from the HOMO of the dopant will go to that of the LUMO levels in the polymer. And so this essentially adds an electron to the polymer, which creates N-doping. In the case of P-doping for integral charge transfer, the opposite happens. So here we can see that the dopant energy levels are lower than that of the polymer homolumo levels. And so what's going to happen is electrons from the HOMO of the polymer will go to that of the LUMO in the dopant. And so in this case, we're essentially losing electrons, which means gaining more holes. So it's P-doping. The difference between integral charge and partial charge transfer is that in partial charge transfer, there's actually going to be a sharing of electrons between the polymer and the dopant. So in the case of N-doping with partial charge transfer, instead of all of the electrons or an electron being given to the polymer, there's actually going to be a sharing of electrons. So there will be a split and a band gap, and essentially the dopant will share some of its electrons with the polymer. And opposite of this is true for the P-doping and partial charge transfer. So we have homolumo levels. What's going to happen is that since the LUMO levels of the dopant are close and if not lower than that of the HOMO of the polymer, electrons will be shared between the polymer HOMO levels and the LUMO level of the dopant. So this essentially sharing of electrons decreases the amount of electrons in the HOMO level of the polymer, which adds more holes. Thank you.